This is question number 24 on the November 2013 higher non-calculator paper. You should be, as soon as you get to this question, realizing that this question is on vectors, and it's a pretty standard question for the end of the paper. It's a 6-mark question altogether, and there are 2 parts, each worth 3 marks. The first part is usually pretty straightforward, and this one is a bit trickier than normal, but it is straightforward, and if you've been doing many past papers, you should have seen a question like this already. Let's read the question. The question says, OA is A, so the vector OA, and it's already labeled A. The vector OB is B, and that's already labeled B. D is a point such that AC is equal to CD. So AC is equal to CD. I'm just going to put a line here to tell me that those two are equal. The point N divides AB in the ratio 2 to 1. So N splits AB in the ratio 2 to 1. So that means this length AN is twice this length here, N. Right, so that's the ratio 2 to 1. And the first part of the question wants me to write an expression for ON in terms of A and B. Okay, so I want to work out, whenever I look at vectors, I think about what I want to work out and how do I sort of use that journey. So I want to work out how to get from O to N. I need to get from O to N, and which part of those lines am I going to follow? So to get from O to N, that vector, I need to travel from O to A, and then from A to N. O to A, and then from A to N. For those of you quite keen, you may well have spotted that I could use another way as well. I could go from O to B and then B to N. And that's totally valid. I could do that, but you're obviously not going to use both or give multiple answers in an exam. I'm just going to go with this one. O to A and then A to N. A to N is going to be a fraction of AB. Now, the ratio is 2 to 1, so that's 2 parts to 1 part. 2 parts to 1 part. How many parts is that altogether? That's 3 parts. So AN is going to be 2 out of 3, and BN is going to be 1 out of 3. What that means is AN is 2/3 of AB. A to N is 2/3 the length of AB. So I could say that my journey is going to be A to N plus 2/3 of AB. Now, if I work out what AB is, the vector A to B means going from A down there and across there. So I need to go from A to O and then O to B. A to O, because OA is just the vector A. If I'm going in the opposite direction, that's going to be minus A, and OB is just going to be B, because they've given us that information already. Now, this is a bit of vectors knowledge that you need to know. If you're going in the opposite direction to a vector that you're given, then it's minus that vector. I'm going to rewrite that as B minus A, and I'm happy with that. I'm going to now put in all the values or the things that I know, because I know OA, O to A, is the vector A plus 2/3 of AB, which I've just worked out, which is B minus A. Now we're just going to tidy this up. A plus, multiply the brackets, 2/3 B minus 2/3 A. And if I just do my workings out on this side, ON is going to be 1A minus 2/3 A is 1/3 A plus 2/3 B. And there you have the final answer. This is pretty straightforward. If you know your stuff, you can do it, and you should be able to get all of the 3 marks allocated for this part of the question. Going on to part B. Part B, if I just move this sheet up a bit, part B says prove that OND is on a straight line. So I'm actually going to draw this out, but they said that prove that OND is on a straight line. Now, I can't prove it by drawing this line. I actually have to prove it mathematically using the vectors, but I want to show that OND is on a straight line. And the way I'm going to do that is to show that the vector ON, which I've just worked out, so that means I need to use that information later on, is parallel to OD. If I could show that the vector ON is parallel to the vector OD, then, well, that means they will both be on a straight line. So what I need to do is I need to find the vector OD. So I'm going to be moving the sheet up and down a bit, and let's first of all write down what the vector OD is going to be. OD means that I need to go from O to A. I need to go from O to A, and then from A all the way to D. Now, earlier in the question, they told us that the point D is such that AC is equal to CD. AC is this vector here. And because this is a parallelogram, that means opposite sides are both parallel and in the same direction. So therefore in the same direction, and they're the same size. So if that there is B, that means AC is also B. And if AC is B, because AC is equal to CD, this one here, CD, is also B. So in order to get from O to D, I'm going to go from O to A, which is A, plus A to C, B, plus C to D, another B. So if I write that out, O to D is going to be A plus C plus C, which once you B and B. Once you tidy this up, O to D is going to be A plus 2B. That is the vector O to D. Remember, I said we're going to compare that to ON, and ON is 1/3 A plus 2/3 B. I hope you can see a similarity between these two vectors. If I take out a factor of 1/3 from ON, I'm going to get 1/3 A plus 2B. That is telling me that ON is 1/3 of OD. In other words, they are parallel. So this means that ON is parallel to OD. So ON and D are on a straight line. There, you've got it, and you should be able to use that fact, use that information to help you understand this question fully and be able to get full marks in it.